Hello friend, good morning, and again we are available with the chapter 2 of Basic Mechanical Engineering, Property of Gases on your favorite channel AVM Tech Android. So today we are going to discuss topic 3 of chapter 2 from Basic Mechanical Engineering, and the topic name is constant pressure process. In the last video we had discussed about constant volume process. Now we have to discuss about constant pressure process, that is on AVM Tech Android. So constant pressure process is also known as isobaric process. It is defined as an isobaric process is a thermodynamic process that occurs at constant pressure. So during this process, volume and temperature of the gas may vary, but the pressure remain constant. So what you can see here in the piston cylinder arrangement, the gas is filled with the pressure, initial condition pressure P1, volume V1 and temperature T1. Now what happens is we are supplying the heat to the system. So what we have to do is we have to keep the pressure constant. So what you will observe here is the volume V will vary, and accordingly temperature will also vary. So what you can see on the graph is the pressure remains same constant, but the initial volume was V1, and when the heat is supplied the volume is increased from V1 to V2. So this is the constant pressure process. I hope it is clear to you. When the heat is supplied, the volume is increased in order to maintain the pressure constant. So what you can see here is we have to find out again the relationship between V and T. So according to the ideal gas, PV equals to mRT. So for constant pressure and at constant value of R, V is proportional to T, or you can say V1 upon T1 is V2 upon T2, and that is nothing but our Charles law. So that state that at the constant pressure the volume of fixed mass of gas is directly proportional to its absolute temperature. Now friend, what we have to do? We have to find out the three values. What is the value of Q? What is the value of change in internal energy? And third is W. So these three things we have to find out. So let's find out it. So now first task is to find out work done. So work done during expansion or compression is W, that is equals to integration between initial volume V1 to final volume V2 into PdV. Now when the pressure is constant, W, that is equals to P into V2 minus V1. And change in internal energy according to thermodynamic equals to mCV into T2 minus T1, that is CV, that is a specific heat at constant volume. So W is available with us, delta U is available. So what is the Q value? That is delta U plus W. So what you can see according to the first law, Q equals to delta U plus W. So what you will observe, Q, that is equals to what is the delta U value? That is mCV T2 minus T1. What is the W value? That is P into V2 minus V1. Now as per the ideal gas, PV equals to mRT, P into V2 minus V1, that is equals to mR into T2 minus T1. So what we have to do is, okay, we have to replace this P into V2 minus V1 of this equation, that is equals to mR into T2 minus T1, and that is placed here. So what you will observe in for this equation, Q, that is equals to mCV T2 minus T1 plus this mR T2 minus T1. So this M T2 minus T1, T2 minus T1, that is common. So what you can see, M into T2 minus T1 is common, and into bracket we will get Cv plus R. What is Cv plus R? Cp minus Cv equals to R. So this value is nothing but a Cp. So what is the heat supplied value? Q, that is equals to mCpT2 minus T1. So Q value is also available, U value is available, W value is available for the constant pressure process. So in the summary, we can see Cp minus Cv is R. The pressure is a constant here. Relationship between volume and T, that is Charles law, that is V1 by T1 equals to V2 by T2. Work done, that is W, that is equals to P into V2 by V1, that is Mr into T2 by T1 according to the gas law. It is positive for expansion process. Change in internal energy delta U, that is mCv delta T, that is T2 minus T1. Heat supplied, that is mCp into T2 minus T1, and the first law equation Q equals to delta U plus W, that is for energy balance. So I hope friend this is very much clear to you. Constant pressure process, these all are relations which you have to remember or easily you can derive if you had gone through this video. Now we will solve one numerical related to the constant pressure process that vary from 3 to 7 mark for your exam point of view. So you can find the problem title, that is a gas occupied 0.05 meter cube at 2 into 10 power 5 Pascal and at 300 Kelvin. It is then heated at the constant pressure. So it is clearly mentioned here, constant pressure process, until its volume is 0.08 meter cube. Find the work done, heat supplied and final temperature. Again the question may be there, also find out change in internal energy. The data which we have to take is M is 1 kg, Cp is 1.005 kilojoule per kilogram and R value is 0.287 kilojoule per kilogram Kelvin. So friend, if all the thing which we have to find out that include W, delta U, Q and final temperature, then this numerical may be of 7 mark. So let us see the solution. So initial first step is to find out work done, that is W, that is equals to P into V2 minus V1. So pressure is given 2 into 10 power 5 Pascal. Final volume, initial volume is given. So here the work done is available with 6 kilojoule value. Unit is very important. Change in the temperature delta T we have to find out. So we know that Mr into T2 minus T1, this Mr into T2 minus T1, that is equals to P into V2 minus V1. So we know what is P into V2 minus V1. M is 1 kg and R is 0.287. So the value is 20.91 Kelvin, that is delta T value. So what is the T2 value? T2 value is T1 plus delta T, that is 300 plus 20.91, that is 320.91 Kelvin. Means the T2 temperature, that is equals to T1 plus delta T, that is 320 Kelvin. Now what is the value of heat supplied? Q, that is equals to mCp delta T. M value is 1 kg, Cp is 1.005, that is given in the data, and delta T, that is change in the temperature, that is known to us, that is 20.91. So approximate answer is 21 kilojoule. So W is available 6 kilojoule, Q is available 21 kilojoule, T2 is available 320.91 or it is 321 Kelvin. So I hope friend this is very much clear to you how to solve the numerical related to isobaric process. So this is the end of this video. Do not forget to subscribe this channel, like this video and share this video as well as this channel to your friends. Thank you.